Yes guys, today we've got a different few styles of question. We're dealing with Fibonacci numbers. And we're proving, well, first question reads, prove that f2n equals the sum of pretty much every odd Fibonacci term before it. Yes, so f is a Fibonacci term. Second question is asking to prove that the 3nth term of the Fibonacci sequence is divisible by 2. Alright, let's start. So, here, where would you start? Well, let's start off with the definition of a Fibonacci term. Fibonacci term says that fn equals fn minus 1 plus fn minus 2. So each term is the sum of the two previous terms before it. Now if you apply that to f to the 2n, well, that equals f to the 2n minus 1 plus f to the 2n minus 2. Now notice f of 2n, f of 2n, f of 2n minus 1, f of 2n minus 1. So we've essentially just ticked off one of the terms of all this sum. So since we've dealt with this, we don't really need to pay any more attention. We need to pay more respect towards here. Well, what happens if we just apply the definition of the Fibonacci term here? So let's put a box around this. And we know this is an even term because 2n minus 2 and 2n even minus 2 even. So f of 2n minus 2 is just f of 2n minus 3 and f of 2n minus 4. Again, if we go up, f of 2n minus 3 would be here somewhere. So we can put another red box around it. Oops, a circle. Then we go into this even term. You sort of see a pattern here. We're expecting one odd term and one even term to come out. So we have f to the 2n minus 5, f to the, not 2, f of the 2n minus 5th term, sorry, 2n minus 6th. Circle our odd term because that's what's needed for our question, so on. Now if we draw 3 red dots, and let's go to f of, let's say 4 for example. And let's say we've just branched off and we've got to this even term. Well, f4 is just f of 3 plus f of 2, f of 1, f2 is just, well, f of 1 plus, well, if you think back to the Fibonacci, f of 2 is just f1 because we start off with 1, 1, 2, 3, 5, so f of 2 term is just f1, so we can say f1. So notice that we have now formed all of our odd terms before f2n. So again, let me just go through it again. f2n was f2n minus 1 plus f2n minus 2. We didn't need to evaluate this further because we need it. Well, that's part of what we're looking for. Then we look at our even term, odd term, even term. Take the odd term, evaluate the even, so on and so forth. And essentially we're just summing all these. So that's that proven. Now onto the second part. Prove that 2 divides f of 3n. Well, like we were doing before, let's just start out by writing the first few terms. So we have 1, 1, 1, 2, 3, 5, 8, 13, and 21. Now let's look for the terms divisible by 2. So this term here, let's write e for even, it's divisible by 2. This term, let's write a few more terms, shall we? 34, 56, and 80, 90. This term here is even, hold up, this term here is even. 34 plus 56. Hold up, made a mistake. 34 plus 21 is 55. So 34 plus 55 is 3 at 5, 8, 89. 89 plus 55, well, that's 90 plus 55 minus 1. 90 plus 55, 145, 144. And here we got even term. Notice how, well, every third term, that's 3, third, 6th, we do 9th, and 12th term is a even, so meaning divisible by 2. So every 3 kth term, let's say, so let's write that better. So f of 3k terms, well, no, every f of 3k terms is divisible by 2, so 2 divides f3k, where k is an element of z plus. So we're told as well that n is also an integer, therefore 2 divides f of 3n. That wasn't that bad. And that's it. That's these 2 questions proven.